Hi guys, today we are going to talk about the GOF-Composite design pattern. It's part of the structural design pattern that help us manage complex systems more effectively. The composite pattern allows us to treat both single object and group of objects in the same way by using a common interface. In simple terms, whether it's only one element called leaf or a collection of elements called composite, we can handle them uniformly, and this pattern is important because it facilitates flexibility in design and also simplifies client code, making it easier to read and maintain.
Composite within the GOF catalog. Composite belongs to the structural pattern group and it organizes objects into three structures: sectional pattern, structural pattern, behavioral pattern. Key concept: 1. Component and interface or abstract class that define operation for both individual object and group. 2. Leaf represents a single object with no children. 3. Composite, a class that implements the component interface and can contain leaf or other composite. For uniformity, although clients should treat individual object and group of objects in the same way. Intent: the composite pattern organizes objects into a tree structure, letting single object and group be treated uniformly to create a tree structure that represents past whole hierarchy. To allow clients to treat individual objects and group uniformly to improve modularity and extensibility by separating components clearly. To enhance usability to organize an intuitive structure. Motivation: this pattern manages complex systems by treating single and group elements consistently. Companies often offer combined products which need a clear logical structure. It simplifies interaction with this logical represent, provide flexibility to add or modify components without breaking the system, enhance user experience by representing options in an intuitive, organized way.
Now let's look at how collaboration works in a composite pattern. First, clients interact with both leaf and composite objects via the same component interface. When a client calls the operation method on a composite, it automatically interacts via its children and call operation on each of them. This process is recursive and it keeps going until all leaf objects have finished their operation. Additionally, a composite can also combine the result from each student before sending them back to the client. And next, the consequence of using a composite pattern. One of the main advantages is how it simplifies client code because clients can work with individual components and groups in exactly the same way. It also improves maintainability since we can easily add new components without changing the existing code. However, there are also some trade-offs. The structure can become more complex as the number of classes grow, and if the hierarchy goes too deep, it may lead to performance overhead.
Case study second scenario เที่ยวด้วยกัน is a travel booking application designed for the Thai market to assist users in planning their trip. The app offers various components such as flights, hotel, and activities. However, it has faced significant usability challenges that negatively impact user experience. Problem: the current version of the app displays individual travel options in separate windows, leading to several user issues. Confusion: users struggle to combine different components into a cohesive travel package. Excessive navigation time: users must click through multiple screens, resulting in frustration. difficulty in modification, adding or removing components from a package complicates the user experience.
In case study solution explanation, to improve the travel application, we apply the composite pattern. We create a travel package class in the component, which can include different options such as flight, hotel, and activity. By combining these elements into one structure, users can manage their trip more quickly and efficiently. The composite pattern organizes all these components in a way that feels natural and easy to interact with. In case study benefit, this solution brings three important benefits. First, enhance modularity. We can easily add a new option into the same structure without breaking the system. Second, improve user experience. A more organized interface reduces confusion and help users quickly see how the three components fit together. And third, higher conversion rate. Since the booking process becomes easier, more users are likely to complete their reservation. And here is our composite pattern UML. The key idea is uniform treatment. Both single service and bundle use the same travel component interface. Flight, hotel, and activity are live. Implement, execute, and price travel package is the composite. It manages children, lets us add or remove them. And when the clients call execute all price on the package, it will get recursively to all children and sum the total price. This high complexity from the UI keep clients more simple and make the system extensible. The trade-off is having more classes and potential overhead in very deep heritage. Overall, it provides a clear and flexible structure for building travel bundles. And this is UML is implemented in code. In the first one is component. In the first part, we have the travel component interface. It defines two methods: book for making a reservation and guest price for returning the cost. This ensures that both simple service and full package follow the same contract. And next, RIP classes. Next are the RIP classes such as flight, hotel, and activity. Each one represents a single travel service. They implement the interface directly, providing their own booking action and returning their individual price. These classes cannot contain outer components because they are the basic building block of the system. And next, composite class. The composite class called travel package, unlike the leaf. This is class can store a list of children. It provides method to add or remove service, and when the client call book, it delegates the operation to all of the children. The price is calculated by summing up the price of all children, which demonstrates the recessive nature of the composite pattern. And last one, clients. We can see the clients code. The clients create individual services such as flight, hotel, and activity, then groups them together into a private package. When it call books on the package, all services are booked automatically. The clients only interact with the travel component interface without needing to know whether it is dealing with a single object or package. This uniform treatment is the key advantage of the composite pattern. In summary, implementing the composite pattern in the theoretical application effectively organizes travel components like flight, hotel, and activities into a cohesive structure. The approach enhances the user experience by reducing confusion and navigation time, making it easier for users like Ananda to manage their vacation package.